Hello there. I'm David Holt with National Comfort Institute. I'll be your guide through HVAC 101, a 60-minute course that introduces you to various concepts related to residential indoor comfort systems. Don't worry, you don't have to sit through all 60 minutes of HVAC 101 all at once. We've broken it down into 6 10-minute lessons. First, I'll help you understand the 3 main components of a residential indoor comfort system. Next, I'll describe the mechanical components involved in a typical residential system. In the 3rd lesson, I'll go over the various equipment types used to properly condition a home. Lesson 4 will provide an overview of what's involved in designing a great indoor comfort system. Next, I'll share many of the installation requirements that must be considered when renovating an existing indoor comfort system. And finally, I'll share thoughts about the proper maintenance and repair of residential indoor comfort systems. That's a lot of valuable information to cover, so let's get started. HVAC stands for heating, ventilation, and air conditioning. HVAC systems can be found all around us. We find them in automobiles, airplanes, trains, and buses. We couldn't operate most offices, restaurants, or hotels without it. Wherever you go, there's almost always an HVAC system close by. In this course, we're only going to focus on the most common HVAC systems found in homes throughout North America. While these lessons are residential focused, many of the concepts I'll share are universal and apply to all areas of indoor comfort. There are 3 main components for every indoor comfort system: the structure that must be conditioned, the mechanical system that delivers the conditioned air, and the occupants that enjoy the safety, health, comfort, and energy efficiency associated with a properly designed, installed, and maintained comfort system. The structural integrity of the home is a critical part of every indoor comfort system. If the windows and doors are always open to the outside, there is no way to control the temperature, humidity, or air quality inside the home. Your comfort would be completely at the mercy of the weather, over which you have absolutely zero control. While the always open door or window scenario is pretty obvious, there are way too many hidden openings in the construction of most houses. Look carefully at this diagram. You can easily see that there are many ways for air to leak into and out of the house. Uncontrolled air entering the home is called infiltration, while air exiting the home is known as exfiltration. To control the indoor environment, the house must be properly sealed to prevent undesired air leakage into and out of the living space. The key to ensuring a comfortable, energy-efficient home is a tight building envelope, a building that is properly air sealed, including exterior walls, ceilings, attics, foundations, roof, windows, and doors. Otherwise, the outdoor weather will control the indoor comfort. In addition, the house must be properly insulated to keep extreme temperatures outside on those hot and cold days. We all want a comfortable, cozy home, but if your home insulation is not up to par, it's nearly impossible to achieve. Many people have experienced a room that's too cold in the winter or too warm in the summer that you just don't want to spend time in. Properly installed insulation keeps the conditioned air within the home much more comfortable, using much less energy. Sadly, many homes across North America suffer from significant air leakage and insulation failures. This makes it extremely difficult for the HVAC system to keep the structure comfortable. Simply put, you can't control what you can't contain. A Yeti tumbler can keep warm things warm and cold things cold because they don't leak and they're well insulated. That's why air-sealed and properly insulated structures are an important part of the indoor comfort system. Heated, cooled, humidified, filtered, and treated air is handled by the mechanical system in the home. There are many types of mechanical systems available, but we're just going to focus on the most common type used in North America, a ducted HVAC system. All ducted HVAC systems have some form of heat transfer equipment, air movement equipment, indoor air quality equipment, ductwork, and controls. When all these components are selected and installed properly, that is the true definition of an HVAC system. The mechanical system acts like the heart, veins, arteries, and lungs of the structure we call home. In a properly air-sealed and insulated home, it's almost impossible to live in the structure without a good mechanical system. We're going to investigate various types of mechanical equipment in our next lesson. The final and most important part of the indoor comfort system is the occupants. Why do I say they're the most important part? Well, because without them, there'd be no reason to even have a structure or a mechanical system to condition the air inside. The occupants decide how they will use the space within the structure. Their usage dictates how their indoor comfort system must be designed. For example, let's say that a room originally designed to be a bedroom is now used as an office with multiple computer screens and lights for Zoom meetings. The additional heat generated by the computers and lights must be accounted for when designing the HVAC system. What if the living room is used as a classroom with 16 students? Do you think the original designer of the home assumed that there would be 16 people in the living room? Nah, probably not. How people use their home is an important variable that must be taken into consideration. When all the components come together properly, the occupants will enjoy the safest, healthiest, most comfortable, convenient, and economical indoor comfort system possible. Here's our definition of occupant safety. The heating and cooling system does not pose an immediate threat to your family through possible exposure to electrocution, explosion, fire, and/or poisonous gas. This is always job number one for an HVAC contractor. We never walk away from an unsafe system. Occupant health is our second priority. The heating and cooling system does not pose a long-term threat to your family through possible exposure to unhealthy airborne pollutants like dust, mold spores, or pollen. Occupant comfort is priority number 3. The optimized heating and cooling system is capable of quietly maintaining a consistent temperature and humidity level throughout each room in your house. Now, it may seem odd that this is number 3, but would you put comfort before your family's safety or health? I sure wouldn't. Convenience is next in line. The heating and cooling system is a worry-free, professionally maintained, performance-monitored, and easily controlled component of your home's indoor comfort system. And finally, economy. The heating and cooling system operates in an efficient manner, thereby lowering monthly energy bills and reducing potentially negative environmental impacts. You know you've done a great job when the customers are smiling, providing 5-star online reviews, referring you to their friends, enrolling in your maintenance agreement program, and happily investing in the products and services that ensure that their home is as safe, healthy, comfortable, convenient, and economical as possible. So that's the first lesson. I hope you better understand that the 3 main components of a residential indoor comfort system are the structure, the mechanical system, and the occupants. In the next lesson, I'll describe the mechanical components involved in a typical residential system. Thanks for your attention.